Welcome to the class, myself Ashwini. Today we are going to start a new chapter, that is our 5th chapter in our second PUC syllabus, theoretical distribution. Already in first PUC we know how to find outcomes of an experiment, and we know how to find the expectation of the expected frequency distributions. We have studied the theory of probability for the occurrence of a conceptual experiments. In experiments, the experiments is nothing but the output of the trial or the experiment. See, in frequency distribution, broadly we have classified into two, as observed frequency distribution and theoretical frequency distribution. Theoretical frequency distribution is nothing but expected frequency distribution. Expected means that we are going to calculate that. That is our theoretical or expected frequency distribution. Observed frequency distributions are always based on observations and experimentation. Observed frequency distribution are always based on the observation and experimentation. Okay. For example, if we toss a coin, if we will get head or a tail. That is the experiment we have done, and the outcomes observed is whether we have got head or a tail. That is our observed frequency distribution. And theoretical distribution are deduced mathematical on the basis of previous experience or theoretical consideration. For example, if we are having last data that we are going to using that we can find the expected or a theoretical distribution. Or theoretical distribution are originated according to certain theoretical assumptions and restrictions. Theoretical probability distributions are derived using the theory of probability for the outcomes of a conceptual experiments. I repeat, theoretical distribution are derived using the theory of probability, because in first PUC we already studied the theory of probability for the outcomes of a conceptual experiments. Probability distribution of a discrete random variable is known as discrete probability distribution. The probability distribution of a discrete random variable. We know what is discrete random variable and a continuous random variable. If we are having a probability distribution of discrete random variable, that is our discrete probability distribution, and a probability distribution of a continuous random variable is known as continuous probability distribution. The sum of here we are having some of the probability distribution we are going to study in this chapter, and here also we have discrete probability distribution also and continuous probability distribution also. We will make the discrete and a continuous probability distribution list. First is discrete probability distribution. Discrete probability distributions. First one is Bernoulli distribution. Second one is binomial distribution. Third one is Poisson distribution, and fourth one is hypergeometric distribution. And similarly we have continuous probability distribution. In continuous probability distribution, we have three methods or three types. That is, one is normal distribution. Second one is student T distribution. Third one is chi-square distribution. Okay, these three are the continuous probability distribution and these four are discrete probability distribution. And if Bernoulli distribution says that how we differentiate this distribution means based on the sample size, Here in Bernoulli distribution, the sample size or x can take the values only 0 and 1. If 0 means it is a failure, 1 is it is a success. Similarly, for binomial distribution, if the number of experiments goes on increasing, then this x value 1, 2, etc. till n value it will be taking. And for Poisson distribution, x will take the value 0, 1, 2, etc. infinity. And in hypergeometric distribution, x is minimum of a comma n. A and n are the parameters. Depending on the parameters, we will take the geometric distribution. And for normal distribution, it is minus infinity less than or equal to x less than or equal to infinity. And chi-square distribution is nothing but the squaring, the square of the normal distribution. So it is chi-square less than or equal to infinity 0 less than or equal to. And here this for t distribution. This t distribution will take only a range. The range of the t distribution is minus infinity less than t less than infinity. This is the range of the t distribution. Depending on this, we are going to see the distributions, or we will differentiate, or we will bifurcate the distributions of this. And today in this class we will discuss about the Bernoulli distribution, that is our discrete probability distribution. Okay, and this discrete probability distributions, first we will see the definition of that Bernoulli distribution. So this definition says, first will be the definition, it says that if x is a discrete random variable with probability mass function, x is a discrete random variable with probability mass function, that is PMF. Probability mass function is nothing but PMF. PMF is P of x is equal to P power x q power 1 minus x, where x can take the value 0, 1 and 0 less than p less than 1, and this is p takes the values between 0 and 1. Okay, and q is always 1 minus p, then x is a Bernoulli variate. X is a Bernoulli variate. The distribution of x is called Bernoulli distribution. The distribution of x, we call it as Bernoulli distribution. You just observe the definition. If x is a discrete random variable with PMF, probability mass function, this is the PMF. This is very important. Okay, and this is the range. X takes the value 0 and 1. Here 0 is failure, 1 means success. Okay, 0 is failure, 1 is success, and this P is the parameter of the Bernoulli distribution, and this takes the values 0 to 1. You just see x will take the value 0, 1, 0 and 1, that's it. We will not put this in bracket, or we will not take any brackets or any square bracket, round bracket, that we will not take. Only we will write x equals, x can take the value 0 or 1. And note, you should see here P will takes the values between 0 and 1, and P plus Q is always equal to 1. We know that the total probability is always equal to 1. That's why P plus Q, that is parameter P plus Q. That Q we will find using, if we know the P value, we can find the Q value. Q is 1 minus P. If we know the P value, we can find the Q value. And if we know the Q value, we can find P value also. And P plus Q is always equal to 1. This is very important. And some of the examples of Bernoulli distributions are number of heads obtained in the tosses of a coin. If I toss a coin, one coin, the possibilities, the outcomes are head or a tail. If my assumption is to get head, then if I get the heads, that is by success, then P is equal to 1. If I get tails, then it is a failure, that is your 0. And number of male children when a baby is born. If a baby is born, the probability of getting a boy baby and a girl baby is always same, that is half or 1 by 2. Chances of getting a boy baby is half, and chances of getting a girl baby is also half. Here if we want a boy baby, then it is our success. Number of bombs hitting the bridge when a bomb is dropped from the aeroplane. If I drop a bomb from the aeroplane, the probability of hitting the earth or hitting the bridge, it will be half and half. Either it can hit the bridge or it can be a failure. These are very simple examples for Bernoulli distributions. And for Bernoulli distribution, with parameter P, we can write it as if X will takes the value 0 and 1, if X takes the value 0 and 1, then our P of X, you just observe this. So I'll take this PMF, P of X equals P power X, Q power 1 minus X. If X equals 0, I'll substitute the X values here. So P0 is equal to P power 0, Q power 1 minus 0. This P0 will be equal to P power anything to the power 0 is 1, Q to the power 1 minus 0 is 1, it is your Q. If X value is 0, then P of X, probability of X is equal to Q value. Similarly, if P of X equals P power X, Q power 1 minus X, if P takes the values 1, P power 1, Q power 1 minus 1, so P of X equals 1, P power 1 is P itself, Q power 1 minus 1 is 0, anything to the power 0 is 1. So if X equals 1, the probability is P, and P plus Q is always equal to 1. Already we know that the total probability should always equal to 1. So after this we have some features or properties of Bernoulli distribution. Features of Bernoulli distribution. Properties or features both are same. Bernoulli distribution has one constant, that is P, which is the parameter of a Bernoulli distribution. The first feature is parameter of Bernoulli distribution is P. Okay, the parameter of Bernoulli distribution is P. Next, if X will takes the value 0, 1 is the range of Bernoulli distribution. X can take the values only 0 and 1. So this is our range, the capacity. Next, for a Bernoulli distribution, PMF is We know that Bernoulli distribution PMF is P of x equals P power x q power 1 minus x, x takes the value 0, 1, 0 less than p less than 1 and q is equal to 1 minus p. While writing the PMF, these three are very important things we have to write as it is, and with that we have to write so that we can solve the problem easily. And the fourth point is in Bernoulli distribution the mean or the expected value will be P, and this is mean, and variance V of x is equal to P into Q, and standard deviation is square root of PQ. And here in this distribution mean is always greater than variance. Mean is always greater than variance. That is P is always greater than PQ. These are the 5 important features of Bernoulli distribution. I will repeat the features of Bernoulli distributions. Here the parameter, only one parameter here we are having, that is P is the parameter of Bernoulli distribution, and the range of the distribution is 0, 1, that is it can takes the values only 0, 0 and 1. And in Bernoulli distribution PMF is P of x is P power x q power 1 minus x, and x will take the value 0, 1 and p will always lies between 0 to 1 and q is always 1 minus p. And the fourth property is the mean or expected value of Bernoulli distribution is p, and variance is PQ, P into Q, and standard deviation is square root of PQ. And in this distribution mean is always greater than variance. Mean is always greater than variance. Next, we will see some problems based on this Bernoulli distribution. If P is equal to 1 by 4 for a Bernoulli distribution, write down the PMF. In examination they may ask these type of problems for 2 marks, or simply they will ask the range of the Bernoulli distribution for 1 marks. Like that you will get the problems or a question. See here P they have given, that is 1 by 4, and write down the PMF. We know the PMF first. First we will write the PMF. So PMF of Bernoulli distribution is P of x equals 1 P power x q power 1 minus x, x takes the value 0, 1, 0 less than p less than 1, q is equal to 1 minus p. Okay, and they have given the p value. You just substitute the p value wherever p is there. Small letter p, not capital letter P, it is small letter p. This capital letter P is probability and small p is the parameter of Bernoulli distribution. You just substitute that. So p of x is equal to, here p is 1 by 4. Using this p value you can find a q value also. Okay, so we know that q is equal to 1 minus p. Q is 1 minus 1 by 4. If I take the LCM, it is 4. 4 minus 1. So q is 3 by 4. Okay, then you substitute that also. We don't know the x value. I'll take as it is. It is 1 by 4 and q value is 3 by 4. I don't know the x value, so I'll remain as it is. So p of x is 1 by 2, 1 by 4 power x, 3 by 4 power 1 minus x, and x takes the value 0, 1. This is the PMF of Bernoulli distribution after substituting the p and q value. Next, write down the Bernoulli distribution with P is equal to 0.25. Here we have to write the distribution. Distribution is nothing but how the values are divided for 0 and 1, that we have to write. Here they have given the P value. First we will find the Q value. Q is 1 minus P. This is 1 minus 0.25. It is 0.75. We know that Bernoulli distribution. For Bernoulli distribution, x takes the value 0 and 1, and this is the total P of x. If I'll write the values, we know that Q is our failure and P is our success. So that here Q means 0, P means P means. So here x, if x takes the value 0, it will be Q, that is 0.75, and if x equals 1, that is P, it is 0.25, and total will be 1. This type of problem they will ask in the examination for 2 marks. You have to divide or distribute the values in a table form. Okay. Next one. If Q is 0.4 for a Bernoulli distribution, find mean and variance. Here they have given the Q value. Q is 0.4. So using this Q value, we can find the P value. P is equal to 1 minus Q. This is 1 minus 0.4. This is 0.6. And we know that in Bernoulli distribution, mean is equal to P, variance is equal to PQ. In features of Bernoulli distribution, we already know about what is mean and the variance. Mean is P and variance is PQ. So P is 0.6. PQ means 0.6 into 0.4. It is 0.24. This is 0.24. Next one. If the parameter of Bernoulli distribution is 0.36, find the standard deviation. See, if the parameter, we know that the parameter of Bernoulli distribution is P. That parameter they have given, that is 0.36, and we have to find the standard deviation. So P is equal to 0.36, and to find standard deviation, it is square root of PQ. Okay, but using this P value, you can find a Q value. So Q is equal to 1 minus P, or 1 minus 0.36. This is 0.64. Substitute that. Square root of 0.36 into 0.64 is equal to 0.48. So standard deviation is equal to 0.48. In examination only you will get these type of problems for 2 marks on this chapter. Okay. Thank you.